Hey everybody, this is our last set of notes video for the semester. We're doing our 12.08 notes with compound probability. So let's start. To find the probability of two independent events occurring in a sequence, we want to first find the probability of each event occurring separately and then multiplying them together. So we are looking at the probability of A and B. Now we've had and before, but our ands that we've talked about before have been one event. Is there one marble in the bag that is red and blue? Is there one student who picked chocolate and vanilla ice cream? Here we're talking about two events. So we could be talking about rolling a dice and then rolling a second dice. That's two separate events. We want to know what's the probability of rolling a 1 and then on the second time a 2. We could be talking about flipping a coin twice. What's the probability of getting heads and then on the second time getting tails? So that is the difference here. And the way you're going to know that it's the difference is by reading the scenario above. If we're talking about two different events, we're going to be multiplying our two events together, the probability of A and the probability of B. If it's just talking about one single person, one person was selected from the crowd, one person was surveyed, one student was asked, then you're going to do the old and that we talked about before. What is the probability that that one thing is A and B at the same time? So if we're talking about two events, we're going to multiply each probability separately. So that's what happens if these are independent from each other. They do not influence each other. If they do influence each other, if we have two dependent events, you're going to do the probability of A. And now that A has already happened, if these are dependent, it is going to affect the probability of B. So what you're really multiplying by here is the probability of B given that A has already happened. Since these are dependent events, A is going to affect the probability of B. So remember, just for future reference, we talked about this before, that is what's called conditional probability. So if you have A given B, remember that's the probability of A and B on the top over the probability of B. It's whatever is given that is on the bottom. Or you could have the probability of B given A. We still have our and on the top. And then we are given A in this problem, so probability of A would be on the bottom. So this and here is referring to that one event and that we talked about before. What's the probability that both of these things happen at one time? That is what this and is talking about. So let's try a problem. Twice you roll a number cube. Remember, a number cube is just a dice with sides numbered 1 through 10. So it's not a normal dice that we have. It's a 10-sided die. We want to find the probability that we roll a 5, then a 7. Another way that you could see this is the probability of 5 and 7. And the reason how you know it's our new probability is because it says you rolled it twice. These are two separate events, a 5 and then a 7. So we're going to find the probability of getting a 5 and multiply it by the probability of getting a 7. We know these events are completely independent of each other because rolling a dice once does not change the probability of the second one, so we're just multiplying it simply. So what's the probability that we'll roll a 5 in this problem? That's 1 5 out of 10 sides. Probability of getting a 7, there is 1 7 out of those 10 sides, and now we are going to multiply them together. If you remember multiplying fractions, you just multiply straight across, or you could put it in your calculator. But 1 times 1 is 1, 10 times 10 is 100. So when you multiply fractions, you do multiply the denominators, whereas in addition, we leave the same denominator. So we have a 1 out of 100 chance that we will roll a dice and get a 5, and then roll the second dice and get a 7. Let's look at B. We want to roll an even and then an odd. So we want to find the probability of even times the probability of rolling an odd. How many even numbers are there in 1 through 10? There are 5 even numbers out of 10. What about for the odds? There are 5 odd numbers out of the 10 numbers. Then we multiply across or put it in our calculator, 25 out of 100. And always reduce your fractions. That means you have a 1/4 chance of rolling an even and then an odd. So are these events independent or dependent? The answer is independent. Why? Because rolling a dice or a number cube once does not change the outcome for the second roll. Something along those lines. If you roll a dice once, it's not going to change the probability of the second one. It has no effect on rolling it a second time. I just realized you can't really see that. Let's scoot this up a little bit. There you go. Okay, let's look at example 3. A jar contains 5 red, 2 pink, and 3 white marbles. If a marble is drawn at random, return to the jar, and then a second marble is drawn at random. We want to find the indicated probabilities. So the fact that we are pulling a second marble tells us that we're using our new AND formula where we multiply them together. Also, notice this phrase, return to the jar. Does that mean that these are independent or dependent events? If you return that marble to the jar, that means that on your second pull of the marble, that if on the second marble, it is not affected by that first marble because you put that first marble back in the jar. So it has no effect on that second marble. So these are independent. So we want to find a white and then a pink. First, let's figure out the probability of white. We have 3 white marbles out of, looks like there are 10 marbles total, times the probability of pink. There are 2 pink out of 10 total. We multiply those across, 6 out of 100, and we'll reduce that to 3/50. Okay, what about both of them being red? So probability of red the first time, we have 5 marbles out of 10, times, we are returning that to the jar. We are putting that red marble back. So on the second pull, even though I pulled a red the first time, I still have those 5 red marbles in the jar because I put that first one back. So 5 out of 10 times 5 out of 10 is 25 out of 100, and that reduces to 1/4. So does the selection of the first marble influence the selection of the second marble? Here the answer is no. And why would that be? It's because we returned the first marble to the jar. Before we pulled the second. Since we put it back in the jar, it's the same number of marbles that we had the first time, so it had no influence on the second probability. Okay. Let's look at example 4. We have 5 red, 2 pink, and 3 white. Seems like it's the same scenario. Except this time we're drawing a marble and then not returning it to the jar. Notice that keyword, not return to the jar. We pull a marble out the first time, and then we are not putting it back. So we are changing the total number of marbles that are in the jar when we pull that second marble out. So let's find the probability of white and pink. So white, we still have the same as before, those 10 marbles. We have 3 white marbles out of 10. But we are not returning that white marble to the jar. We are keeping it out. So now instead of 10 marbles in the jar, we now only have 9 marbles in the jar. We took that one white one out. How many pink are in there? We didn't take any pink out, so we still have 2 pinks left in that jar, but we do have 1 less marble total. That is what happens when you have dependent events. This is our, B given A probability that was in the formula that we wrote down earlier. Since these are dependent, that second probability is going to change because of what happened the first time. These are dependent events. So let's multiply that across. We have 6 over 90. Let's see. I'm just going to double check myself with the calculator. When I reduce that fraction, I get 1/15. Here we go. What's the probability that both marbles are red? So new problem. Go back to that original 10 denominator. How many red do we have? We have 5. Now we're taking that first red marble out, and we are not putting it back in the jar. That means we only have 9 marbles total in the jar. But if that one was red that we left out, how many red do we have for the second marble? We no longer have 5 red marbles. We took one of them out. Now we only have 4 red marbles. If you are pulling the same thing twice, not only is it going to affect the denominator, it could also affect the numerator. So that gives me 20 out of 90. That reduces to 2/9. Okay. Okay, so as I said before, when we're talking about and, we have now 2 ands we're talking about. Before today, we had our one event and. What's the probability that one thing has both of these things at the same exact time? And now we have a new and, where we're talking about 2 separate events occurring. So far, we've only seen example problems where we're talking about those 2 separate events occurring. And the reason why we knew that is because it said that we were pulling a marble twice. So let's look at this new problem. So we have a jar of marbles, 5 red, 2 pink, 3 white, same as before. Here it says we have a single marble that is drawn at random from the jar. We want to know what's the probability that that one marble is white and pink. We are not going to be multiplying white times pink together. And the reason why is because we're talking about a single marble. We're not talking about 2 separate marbles pulling them out of the bag. One marble that is white and pink at the same time. Is it possible when we have 5 red, 2 pink, and 3 white marbles that any single marble is going to be white and pink? No, none of these marbles are white and pink, so here our answer is 0. The probability is 0. That is not ever going to happen to have a white and a pink. So please make sure when you're answering some of these questions that you go back and look and make sure that you're talking about one event. It's just is it possible for one thing to have both of these at the same exact time? Or are we talking about 2 events where we have to multiply the probabilities together? So there is a difference. Make sure you understand what type of problem you are answering. Let's look at example 6. A player rolls a pair of 6-sided number cubes. What is the probability of throwing 2 odd values? So we're talking about a pair of those dice. It means we have 2 events going on, dice 1 and dice 2. We want to know what's the probability of throwing 2 odd values. So on our first odd, so it's the same thing as getting an odd and then another odd. For our first odd, how many odd numbers are there on a number cube? There are 3 out of 6 times. Now with our second dice, is the second dice going to be affected by the first? No, it's not. So we're still going to have 6 sides total, and there are only 3 odd. So 3 out of 6 times 3 out of 6, that's 9 out of 36, which reduces to 1/4. What is the probability of throwing a sum of 7? What is the probability of throwing a sum of 7? Okay, so first let's think about our total. How many total marbles how many total sets of dice would sum to the number 7? That's what we need to figure out. An easy way to do this, instead of making a list, if you think back to the very first day of notes, is thinking about our total outcomes. Without making a list of our sample space, our total number of outcomes, how could we just find the number? To find the number, we could use the fundamental counting principle. So for our first dice, we have 6 options, and we can multiply that by our second dice. How many options does it have? It also has 6. So it means if I multiply these together, that will tell me how many different combinations I would get with those 2 die. Here we have 36 outcomes total. Now we want to see, out of those 36 outcomes, how many of those are going to sum to the number 7. I think the easiest way here is to just make a list. So if my first dice is a 1, my second dice would need to be a 6 to be 7. If my first dice is a 2, my second would be a 5. If my first dice is a 3, my second number would need to be a 4. If my first dice was a 4, my second would need to be a 3. Now that is different than 3 plus 4. Even though these are the same 2 numbers, they are technically 2 separate events. The first dice here is a 3, the second one is a 4. That is different than the first number being a 4 and then the second number being a 3. So same thing, 5 plus 2 is different than 2 plus 5, so we are going to count it. And then finally we have 6 plus 1, that also counts. So how many total outcomes sum to 7? There are 6 outcomes that total to 7. When we reduce that, that equals 1/6. Okay, the last one. A nationwide survey showed that 75% of teenagers in the United States own a smartphone. If 5 teenagers are chosen at random, what is the probability that all 5 own a smartphone? What this question is asking is, what's the probability that I pick the first teenager and they have a phone, and then a second teenager and they have a smartphone, then a third, and then a fourth, and then a fifth, that all 5 of them have a smartphone? You can view this as it having 5 events. Here is teenager 1, and we're going to multiply that by the probability for teenager 2, times the probability for teenager 3, 4, and 5. And we will just multiply those probabilities together because all 5 of those are separate events. So for our first teenager, what's the probability that they own a smartphone? 75%. So 0.75 is how you would write that as a decimal. So for our second teenager, what's the probability that they have a smartphone? It's still 75%. For our third, what's its probability? 75%. It's going to be 75% for all 5 of them. So we can just multiply this in our calculators. A shortcut for this is also to do 0.75 raised to the 5th power. That means you are multiplying that 5 times. If you don't want to multiply that all out in your calculator by doing 0.75 times 0.75, you can just raise it to the 5th power. And so I get 0.237, which is 23.7%. That would be the probability that all 5 teenagers chosen at random would have a smartphone. And that's it, you guys. Complete the 12.08 homework and be ready for the live chat. Talk to you later.